You know, from ordering food to streaming a movie, our lives are run by really complex systems. But have you ever stopped to think about how it all actually works behind the scenes? Well, today we're going to pull back the curtain and map out that invisible journey, turning a whole lot of chaos into some beautiful clarity. Okay, think about the last thing you bought online. You find it, you click buy, and then a couple of days later, a box just shows up at your door. It feels like magic, right? But what's actually happening in between your click and that delivery? Where does all that information go?
The truth is, it's this incredibly complex web of information flying around. I'm talking your order details, your payment info, your shipping address. All of that has to bounce between different departments, different computer systems, maybe even different companies. Just keeping track of it all is a massive headache.
And that is exactly where something called a data flow diagram, or a DFD for short, comes into play. Just think of it like a map. It's a surprisingly simple visual way to see exactly how data comes into a system, moves around inside it, and eventually leaves. Now, this is probably the most important thing to get about DFDs. They show you what a system does, not how it does it. We're just focused on the journey of the information. We don't care if a process is handled by a supercomputer or a person with a pen and paper. All we care about is what happens to the data. All right, so if we're going to read this map, we need to learn its language. And the good news is, it's super simple. There are really just four main symbols you need to know. Let's break them down. Okay, here are our four building blocks. The process, that's the rounded rectangle, is where something actually happens. It changes the data. The data flow is the arrow. That's literally the road the data travels on. The data store, the open rectangle, is like a filing cabinet where data hangs out for a while. And finally, the external entity, the square, is anyone or anything outside our system that either sends us data or receives it, like a customer. So with just those four symbols, we can map out pretty much anything. But the real magic of a DFD is how you can look at a system from different levels of detail, kind of like zooming in and out on a map on your phone. We always start from the highest possible view, what we call the 10,000-foot view. This is known as a level 0 DFD, or a context diagram. Its only job is to show the entire system as one single bubble and how it interacts with the outside world. It basically draws the border for our map. So, check this out. Here's a level 0 for a simple food ordering system. The whole system is just that one process in the middle. We see the key players outside of it, the customer, the kitchen, the manager, and the main data flowing back and forth. It's clean, simple, and gives you the perfect overview. But we all know there's a lot more happening inside that one big process bubble, right? So what happens when we double-click on it and peek inside? And bam, it explodes into a way more detailed map. This is what we call a level 1 DFD. See how our one big process has been broken down into its main parts, like receive order and produce reports? And we're now seeing our first data stores, like the inventory file. It's the exact same system. We've just revealed the next layer of detail. This whole idea of breaking down a diagram into more and more detail has a name. It's called leveling or decomposition. And you could keep going. You could take any one of those level 1 processes and explode it again into a level 2 diagram to get even more granular. Now, this brings up a really important question. As we're creating all these different maps, these different levels, how do we make sure they all actually line up? How do we stop the map from becoming a confusing, contradictory mess? The secret is a simple but powerful rule called balancing. Take a look. On the left is our simple level 0 diagram. It's got two inputs, A and B, and one output, C. Now look at the more detailed level 1 diagram on the right. Even with all that new stuff happening on the inside, the data flows that cross the system's border are identical. Input A, input B, and output C. They have to match perfectly. This is what keeps the whole map consistent. Okay, so balancing is a huge rule. But there are a few other common sense rules we need to follow to keep our maps logical and easy to read. Think of them as the rules of the road for avoiding data traffic jams. Rule number 1 is super simple. Data can't just magically flow from one data store to another. I mean, think about it. A filing cabinet can't just send a folder to another cabinet all on its own. Something has to go get the data and move it. And in a DFD, that something is always a process. This visual makes it crystal clear. The diagram on the left, where two data stores are trying to talk to each other, that's an illegal move in the DFD world. The correct way, on the right,
always has a process sitting in the middle, doing the work of moving the data.
Here's another big one. Data can't flow directly between two external entities on your diagram. And why is that? Well, because your DFD is a map of your system. If a customer is talking to a supplier directly and your system isn't involved at all, then that conversation is, by definition, outside the scope of your map.
Just like before, this slide shows you what not to do. That direct line between two outside entities is a no-go. If that interaction is actually important to your system, then the information has to pass through one of your processes, like you see on the right. This is really how you define your system's boundaries.
And finally, a rule that's just pure logic. A process is supposed to transform data, right? That means it has to take something in and produce something out. If a process only has inputs, we call it a black hole. Data goes in and just vanishes. If it only has outputs, we call it a miracle. Data just appears out of thin air. Neither of those makes any sense. So, after all that, why go through the trouble? What's the real power of drawing one of these maps? Let's quickly sum up the big takeaways.
When you boil it all down, DFDs do a few incredibly powerful things. First, they bring clarity to complex situations. Second, they act as a common language that both technical and non-technical people can understand, which is huge for communication. And maybe most important of all, they get everyone to agree on what the system needs to do, long before anyone starts arguing about how to do it. It's the blueprint.
So, I'll leave you with a final thought to chew on. Think about your job, a hobby, or even something like planning a vacation. What's a complicated process that you deal with? Do you think you could sketch out a quick DFD to make it easier to understand or explain to someone else? If you found this breakdown helpful, do us a favor and hit that like button, share it with your team, and be sure to subscribe to Tech Talk 101 for more explainers just like this one. Thanks for watching.